Welcome back, friends. Today we will be going through a fascinating experiment in which we will use a cardboard, make a circle, and we will mark a hexagonal inside this circumference of a circle. And according to that, we will cut it and make a arrangement of that hexagonal so that we can make the round magnet attached with a motor to rotate in between this cardboard center of that, which is surrounded by copper coil around it. Copper coil number of turns we will make and see that whether it can generate energy or free energy or not. So we can start with the mesmerizing experiment. For that we will use the tools as per requirement. So we can use the cardboard made, we will cut the cardboard into a hexagonal shape and make that arrangement. According that cardboard is cut into a hexagonal shape, we can make that arrangement. Once it is done, we have done and completed the arrangement like this. So we have a hexagonal cut of that circular and six faces are there, and we have made an arrangement of six hexagonal face for which we have wounded a insulated copper wire and insulated spring coil over it. Once it is been done, we have made an arrangement with this to mount the bulb for that. Once it is been done, next we will keep it aside and take a motor over which this arrangement has to be mounted. So we will take the DC motor which is mounted in the arrangement in this form, so that it is fixed with the motor, round motor. So once it is been done, now we will make this arrangement to fix here, and we will mount, once it is been fixed, we will make this arrangement to fix over this motor. Before that, we will fix this with a two-sided tape to fix over this. So once it is been fixed with the two-sided tape, we will mount the motor over it. So we will cut the two-sided tape according to its necessity. We will measure the length. According to that, we will cut it. So according to that, we will cut it and fix this motor. On the both the side, we can attach this so that it can fix rigidly over the cardboard. Once it is been done, so we will fix this arrangement over the cardboard. Once it is been done, next we will take the arrangement of this hexagonal cardboard which we have cut and made in this form. So we have made a 1, 2, 3, 4, 5, 6 side, and we have made an arrangement so that we can mount. Once it has been done, this is been fixed over the board. Now next we will mount the arrangement of this, and in the center of this we will fix the magnet as possible. Now we are fixing this over the center of the shaft of the magnet. Once it is been fixed, so before that we have to remove the two-sided tape insulation so that it can fix to the base of the arrangement. So we will remove that so that it can fix to the base of So we have removed the insulation. Now we will fix it on the shaft of the motor. So we have fixed and press it so that it can fix. Now we have mounted this over the shaft of the motor. Once it is been done, next it in the center position so that now we will fix this cardboard over the shaft of the motor. So once it has been done, press it little bit so that it can fix firmly over the cardboard. So once it has been done, next we will fix the round magnet over the shaft of the motor and see that it is free to move. Tightly fix it. Once it has been done, now we can fix the winding of this insulated copper wire, which is wounded over the hexagonal arrangement, and in between that this round magnet is rotating. Once it is been done, next we will connect these two points of the insulated copper wire to the terminal with forward bias diode and filter capacitor. So once it is been done with the connector point, we can connect these with a forward bias diode and a connector. So we will connect this with the insulated with the terminal. Take the solder wire and insulate the terminals to the wire. Next, connect another terminal to the other point of the coil. Once both the two terminals are connected, now we will connect it with the forward bias diode like this. One terminal with the forward bias diode and a filter capacitor. We'll fix the two screws for the point of terminals to make the terminals. Once the terminals are fixed, now we will solder the wire to the terminals. Solder it properly so that there is no dry solder. Once the terminal are fixed, now we will connect this one terminal of this copper wire to the one end of the terminal. And next end to the next terminal. Once it is been fixed, connect the filter capacitor. Once the filter capacitor is been connected, so we have completed the arrangement on the insulated copper wire which is wound over this hexagonal cardboard, and also the spring coil to make a maximum number of turns so that maximum flux can link the coil when this round magnet is rotating in between this cardboard. So the ends of the coil are connected to the two terminals of the wire. One is connected to the forward bias single diode to make a half wave rectification, and another to the black two terminals with the filter capacitor to filter out residual AC. Once it is been done, next we will fix it properly. So once it has been done, now next we will connect the bulbs to over this so that to check whether the EMF is generated or not. We have made an arrangement here of the bulb in a parallel connection, 3 bulbs, 1 2 3 bulbs in a parallel connection. All the 3 bulbs are attached parallelly to each other, and next we will mount this arrangement over this stand and connect it to the terminals to check whether the EMF is generated or not. Once it is been connected to the motor and see giving a turn, we can generate EMF or not. So for that we will fix a two-sided tape over the 2 points of this junction and fix this arrangement over that. So once it has been done, now we will fix these points over this and fix the arrangement of this bulb over this. Once it has been done, now fix the two-sided tape over this cardboard and fix the arrangement of the DC bulb which are connected in parallel over this arrangement to check whether EMF is generated or not in the coil. So now we will make this arrangement of the bulb to mount over this and of the base so that it can fix rigidly. Once it has been done, now we can connect the two terminals to the point of the bulb. Now before that we will connect the terminals of the motor to the terminals. So for that we will solder the wire of the motor to the terminals. Both the terminals we have to connect. Once the terminals are connected, all the arrangements are been finished. Now here the arrangement are made in such a way that the magnet is rotating in between the hexagonal cardboard made arrangement. In between this the motor rotates and it is surrounded by insulated copper wire and insulated copper spring coil also. The ends of this coil are connected to the two terminals made here with a filter capacitor and a power diode, making a half wave rectification and the filter capacitor to remove the residual AC and produce a pure DC. The two terminals are then connected to the motor which is rotating this magnet. So once we will give a turn and see that whether the EMF is generated or not, and once the EMF is generated, it will rotate the magnet by its turn, and then we can check whether the EMF is generated or not with the help of this DC bulb which will glow, showing that maximum EMF is generated. Now we will give a turn to the magnet and see whether the magnet rotates, generating the EMF or not. For that we will give a continuous turn to the magnet with the help of a hand and see whether the magnet rotates or not. So we have to give a maximum turn in order to make it rotate. You have to give a maximum turn in order to rotate it. Slowly it has started to rotate. Now if you give a speed turn, then it will rotate. So once the turn is given, the magnet starts to rotate, generating a EMF in the coil. Once the EMF is generated, this is given to the motor through this wire. So the magnet starts to rotate in between the coil in maximum speed. Now with the help of a multimeter, you can check whether the EMF is generated or not. We will take the multimeter and check whether the EMF is generated in the coil or not. We will keep this in a 20 volt range and check whether the EMF is generated or not. So once it has been done, now we can check whether EMF is again on the multimeter and check how much voltage is being generated here. So here you can see that three point 3.33 volt is being generated. DC 3.33, nearly 33 volt is being generated. So this, now we can check with the glowing of bulb whether how much voltage is being generated. So for that we have to connect this DC bulb to the terminals of the point. So here the glowing of bulb indicates that EMF is generated in the coil. This mesmerizing experiment shows the discovery of a dynamic of magnetic forces that play into producing the electrical energy in the copper coil, thus producing electricity EMF in the coil, and thus these three DC bulbs glow, showing that EMF is generated whenever the magnetic flux linking with the coil changes. We have made an arrangement that the magnet rotates in between these copper coils, and once the magnet rotates in between this copper coil, maximum flux is linking with the coil, and whenever the flux linking with the coil changes, EMF is generated. With that same EMF we are giving it to the motor, which rotates the magnet in between the coil, and same is connected to the bulb, thus producing EMF in the coil. So this shows that that EMF is generated, and the glowing of bulb indicates the generation of EMF in the coil. Thus, the experiment shows that EMF is generated in the coil. Friends, in this captivating video, witness the mesmerizing interaction between a rotating round magnet and a uniquely designed cylindrical cardboard structure formed in a hexagonal shape. Inside the ingenious creation is a copper coil wound around it. As the magnet spins within the cardboard structure, it generates a electromotive force EMF in the coil within the coil. The fascinating part lies in change of flux linking with the coil due to rotation of magnet leading to illumination of the bulb. This glowing of bulb beautifully signifies the generation of EMF through this dynamic interaction between the magnet and the coil. For more captivating experiments and insightful exploration like this, friends, please consider subscribing to our channel and dwell into the deeper into the world of science and witness the marvelous of physics unfold before your eyes. Please subscribe the channel and press the bell icon so that whenever I create such videos, the notification arrives to you. Please once again subscribe the channel. Your subscription will motivate me to create more videos for you. Thank you very much.